So circumcenter constructions, a circumcenter is a point of concurrency where all three perpendicular bisectors meet. So we're going to construct a perpendicular bisector of, technically you're really supposed to do 3 sides, but once you have 2 of the sides, you can actually stop. So I'm going to put my needle on one of the vertices of my triangle. I'm going to make sure this is open more than halfway for the length of the segment that I'm using. I'm going to extend it below, make an arc. You don't want to go back and forth. Try to do it light so that way your paper doesn't look a hot mess. Do one up here. So I have 2 arcs. I'm going to use the same segment on the other vertice. Not changing my compass at all. I'm going to make an arc up here and an arc down here so that way they intersect. You're looking for these 2 intersections. I'm going to connect them. That's constructing a perpendicular bisector of that segment. Perpendicular bisector creates a 90-degree angle, telling me that this segment is congruent to this segment. It is not an altitude. It is not coming from the vertice. So now I'm going to pick another side of my triangle to do the same exact process with. If you need to turn your paper, then by all means, turn your paper. So I'm just going to use this side right here. Same thing, put your needle on one of the vertices. You don't want to extend it past your triangle because that's not going to make any sort of sense. You want it more than halfway. So I'm going to do one down here. Without moving that inside piece, come up, make an arc. Then I'm going to do the same thing, flipping it. Don't move it, keeping that same measurement. Make an arc. So you should have a total of 4 arcs. Oh, this one's not long enough, so I'm going to go back and make that a little bit longer. Okay, there we go. So you should have technically 4 arcs. 1, 2, 3, 4. I'm going to connect these 2 intersecting pieces. That's a perpendicular bisector of that side of my triangle. So point of concurrency is where these meet at. So I know there's a lot going on in your paper right now, but you're looking for where the perpendicular bisector meets with the other perpendicular bisector. So that is right here. That is called your circumcenter. These are all different types of centers of triangles, technically. So I'm going to label this. Where should I label it? Technically, if you were to find the other perpendicular bisector, it would also meet through that point. So if you want to, you can really do that 3rd side if you really want. So now what we're actually going to do is we're going to take our needle. We are going to put the little circle that we're using. We're going to put that on the circumcenter. The whole point of the circumcenter is so that way it's actually calculating the radius. This is literally the middle of my triangle. If I were to extend this and open it up to one of the vertices of my triangle, if you do it right, it should also take you, without moving it, to the other vertice. Then it should also take you all the way over here, if my paper towels weren't in the way, over here to my other vertice if you don't move it. There it is. So what I'm going to do is I'm actually going to construct a circle around my triangle. So find one of your vertices, make sure you hold this down, make sure it doesn't move from that circumcenter. And I'm going to take my pencil. Oh, my paper towels are in the way. Scoot this over. The more you do this, the better you'll get. But it should technically touch every single vertice. You can tell that this one's slightly off. This one's fine. this is telling me that this is actually the radius of my circle from the distance from each vertex to the circumcenter. This is equidistant from here to here, from the circumcenter to this vertex, and the circumcenter to this vertex. Those radiuses are all the same. So we're gonna do the same thing. I want you to pause the video if you need to, and you are going to try your best, use a protractor if you need to make a right triangle. I think mine is slightly off because I drew this from scratch. It's pretty close though. So take a minute, draw a right triangle. I'm just gonna get started. If you need to, pause your video. Now we're gonna do the same exact thing. We're gonna find perpendicular bisectors of this. So I'm gonna use, it doesn't matter what two sides I use, I'm just gonna use this side because it's right here in front of my face, and it's, extend this to a little bit more than halfway. You're gonna make an arc below and an arc above. Pretend like it's just a segment by itself. Without moving it, I'm gonna flip to the other side of that same segment. Make the arc above, make the arc below. You should have two intersections. You're gonna connect those. That's creating your perpendicular bisector of the base of this triangle, unless you didn't use the base. Perpendicular, telling me those two segments are congruent. I'm gonna do the same thing with one other side. So in this case, I'm gonna use the hypotenuse because why not? If we have a hypotenuse, we have to use it because it's the hypotenuse and it's special. Okay, so extend it more than halfway. Make sure you are not less than halfway of your segment. So I'm more than halfway. I'm gonna make an arc out here. Same arc on the inside. Now I'm gonna flip it, go to the opposite vertex that I'm using, opposite endpoint of my segment. Make an arc out here. Make an arc intersecting with the arc I just made. So I got kind of close with that one, but technically it has an intersection. I'm gonna use my two intersections, this one and this one that I just made. This is a perpendicular bisector. So these are congruent to each other. They're not congruent to this one. So that's why I put two tick marks there, one tick mark here. So once you have two, you're technically done. Now, if you notice, and if your right triangle is actually perfectly 90 degrees, what should happen is that your circumcenter should actually lie on the hypotenuse. So mine is slightly off. It's more towards the inside, which tells me my right triangle is technically a little acute. But if it's perfect, then it should technically lie on its hypotenuse. I did one earlier, where is it? There it is. And I didn't measure again, and my right triangle was technically slightly obtuse. So the circumcenter was outside of the triangle. If it's an acute triangle, it's on the inside. If it's a right triangle, it's right on the hypotenuse. If it's an obtuse triangle, it's technically on the outside. But that's for another day. So what we're gonna do is we're gonna do the same thing. We are going to make a circle going around our triangle by using our circumcenter. So find your intersection, open your needle to one of the corners, one of the vertices of your triangle. If you wanna make sure it kind of works out, you can check before you actually draw it in. Be careful while you're doing this. Try to do it in like one swoop. Don't try to pick up and move. Of course, my paper towels are in the way because that's what I'm using to hold up my phone. There we go. Oh, that's nice. So, that is your circumcenter. So we're gonna do one more. If you need to, pause the video. We're gonna do an obtuse triangle now. Okay, so your obtuse triangle, you're gonna wanna make sure the larger your angle is, the larger your triangle technically, the obtuse angle necessarily, not the triangle itself, but the angle, the bigger the circle is gonna be. So I made sure to kind of put this one in the middle. This is roughly, if you wanna know kind of how big it is, it's like 2.5 inches, roughly, okay? Doesn't have to be exactly like mine, but make an obtuse triangle, and then we're gonna do perpendicular bisectors of an obtuse triangle. Starting with one of the vertices, extend it more than halfway, mark it below, mark it above. Flip it to the other side of the segment. Using the same measurement, mark it below, mark it above. Connecting those two, which is making a perpendicular bisector of the segment, not the triangle technically, but perpendicular bisector of the base of the triangle, since I decided to use the bottom of the triangle first. Now I'm gonna pick another side, doesn't matter which side you use. I'm going to use this side over here, because why not? So I'm just gonna turn my paper. Same thing. Now right now, you wanna make sure it's not more than the triangle. You're gonna go more than halfway, less than the full length. Make an arc below, make an arc above. Switch from one vertice to the other vertice that you're using. Make an arc above, make an arc below. I think I moved mine accidentally. Then I'm gonna connect those two. And that is telling me that's the perpendicular bisector of this portion of my triangle. And I wanna know where these angle bisectors intersect. So notice I was about to draw that in, but it wouldn't make sense because I need them to intersect. So move your ruler accordingly so that way your angle bisectors, or your perpendicular bisectors, I'm sorry, intersect with one another. Because the whole point of this is to actually have them crossing paths. So in this case, it's out here. This is the circumcenter. Whenever you have an obtuse triangle, the circumcenter falls outside of the triangle. If it's an acute triangle or an equilateral triangle, it falls inside the triangle. If it's a right triangle, it falls on the hypotenuse. So once I have the circumcenter, this is actually finding the radius from the circumcenter to each vertice of my triangle. So I'm going to test this theory out. I'm going to open up to this one. And then I'm going to check to make sure it hits this one. And then I'm going to check to make sure it hits this one. Nice. And then once I feel comfortable and I'm trying not to move, you are going to attempt to make a full circle going all the way around. Oh no. There we go.